Hello there, welcome to my question of the day. This is number 32 in a series I've been running most weekdays on my Facebook page and on my YouTube channel. And in this question, we've got to solve a pair of simultaneous equations and then sketch a diagram to represent the answer. Now, I can see that I have one equation that has got powers and exponents in, and one equation that is linear. And what I'm going to do for this one is that the linear equation, I'm going to change the subject. I'm going to make x the subject, and I'm going to make it 3y add 10. Since I know that x is actually equal to 3y add 10, what I'm going to do is substitute that expression for x back into the equation that I believe is the equation of a circle. Maybe you've noticed that too. So therefore, I can see that x squared becomes 3y plus 10 squared, and y squared is equal to 50. And now that means I have one equation with one unknown, so it must be possible to solve. I'm just going to remind myself that squared means I'm multiplying by itself. Sometimes having it written out like that enables you to see that you're going to get 4 terms when you multiply it out. So I've got 9y squared, I've got 30y, and another 30y at 100, and y squared is equal to 50. So therefore, I have 10y squared. I'm just going to tick those off so I know that I've added those. I've got 60y's, just tick those off as well. And I've got 100, and then I'm going to subtract 50 from both sides, so I've got to add 50 equals 0. I think what I'm now going to do is I'm going to divide everything by 10. Every single term in my equation I'm going to divide by 10 on both sides. I can do that because I have an equation. So I've got y squared, and I'm dividing by a constant, not a variable, so I won't miss any solutions by doing so. And that's very important when you're solving equations. And then I've got a quadratic that I can factorise really nice and easy, which shows, therefore, that y is equal to -5 or y is equal to -1. Now remember earlier that I said that x is equal to 3y add 10. So therefore, when y is equal to -5, x is equal to 3 times -5 add 10. And that must mean that x is -15 plus 10, which is -5 as well. When y is -1, x is going to be 3 lots of -1 add 10, and x therefore is going to be -3 plus 10, which is 7. So therefore I have 2 pairs of solutions. And my pairs of solutions are -5, -5, and 7, -1. And if I look back to those functions where x squared plus y squared is 50 and x subtract 3y is 10, I've now got to figure out what this actually looks like. Now the first equation is nice and easy because I can see that's an equation of a circle. And I know that its centre must be the origin, and the radius squared is 50, which therefore means that the radius is going to be the square root of 50. And I know that 50 is 2 lots of 25, so I'm going to write 5 root 2. And there is my answer. But when I think about what the other function looks like, really, if it's linear, I want to write it as y being the subject. And if I do that, I can therefore say that 3y is x minus 10. My brain likes it better written like that, which means that y is equal to 1/3 of x subtract 10 over 3. Now I know that that is the equation of a line. I know that the gradient is always the coefficient of x, and the y-intercept is always the constant, is -10/3. So the remaining task is I've just got to represent what this situation would look like. So the first thing I'm going to do is I'm going to draw my circle equation, which is x squared plus y squared equals 50. So I have a circle, something like that. Let's just label that. And I know that my line must cut through the circle in 2 places because, of course, I have those 2 pairs of solutions. Now, negative 5 is going to be somewhere in the bottom left quadrant, and 7, negative 1 is going to be somewhere in the bottom right quadrant. But if my gradient is a third and my line is going to cut through at negative 10/3 on the y-axis, I must have a line that cuts a circle in 2 places, and that's going to be one of my solutions. It doesn't matter, and it's not to scale. All that matters in a good mathematical sketch is that my solutions are roughly in the quadrants where they should be, that the line intersects a circle in 2 places, which it does, and that the circle has approximately the correct centre and the correct radius. So I do believe that is what that situation would look like when drawn. Mathematical sketches do not need to have a scale or anything like that. I should really label the axes, but I've labelled those important values. Maybe if you wanted to be extremely rigorous, you could label the points of intersection with the x-axis, which would be 5√2, and negative 5√2, and 5√2, and negative 5√2. Oops. And you could also label negative 10/3, where that line cuts through the y-axis. And if you really wanted to, you could find that point of intersection there. And that point of intersection there is where y is equal to 0. So 0 is a third of x, subtract 10/3, and therefore 10/3 would be equal to a third of x, and therefore x would equal 10. So that's what a good mathematical sketch should show. Absolutely no scales or anything like that, and I've got all the important values there that I would ever need. Thank you very much for listening. I've got another question of the day on my Facebook page. Please head along to that. If you want to leave any comments, please do so below, or again, go to my Facebook page. Thanks ever so much. Bye bye.